Yeah. All right, so solving equations with logs and exponentiation, that means we're either going to use a log to solve it or we're going to use exponentiation to solve it. Those are inverses of one another. So if there's a log in the problem to start with, we're going to use what's called exponentiation, which really isn't, it's fancy sounding, but it's really not that difficult of a concept. So the first thing we need to look at with any equation that we get is really, can we condense either side of the problem or write that as one log? Especially if there's a log in the problem, we want a log, either on one side, or if there's multiple logs, maybe both sides is the better thing there. So could I rewrite either of these sides? How could I rewrite the left side? Yeah, log 5 of x squared. Log base 5 of x squared and log base 5 of 9. Now, they're both log base 5s, so what should that mean about the problem? That they're going to cancel each other out. Now, what cancels them? That's where we've got to get this. That yes, it should be x squared equals 9, the equation that we need to solve. But what gets rid of the logs is an exponentiation. And what you want to do when you exponentiate a problem to get rid of the logs is you take the base, whatever the base of the log is, and make that the base of an exponential. So you're taking 5 and making it the base and making those two pieces exponents then. It's legal because you're doing it to both sides. Okay? It's legal because you're doing it to both sides. What happens then is you've got 5 to the log base 5 of something, just like number 1 on the quiz. You cancel out the base 5 and the log up here. So that's where the x squared is coming from. And then 9. Just 3? Yeah. If we're going to solve that, we take the square roots. It's plus or minus 3, technically. So that's two answers. X equals positive 3, x equals negative 3. We need to check those to make sure that they're legal to put back in the original problem. Which one of those is not going to work? Why? That's right. We can't take the log of what kind of number? A negative, so we're going to throw out that negative answer. Because when we put it back in the original, we get a log base 5 of a negative 3, which we cannot do. Okay? Going back to the original problem. Now, does that mean you're always going to throw out the negative answer? No. Most of the time you will, but you won't always. So don't just say, oh, it's a negative answer, I'm throwing it out automatically. That's not going to happen every time, but it does happen quite a bit. So it's very common for that to happen. All right, let's look at this one. Log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. Okay, yeah, the left side can be condensed to a multiplication problem, right? So that'd be log base 5 x plus 6 times x plus 2 equals 1. Well, the other side doesn't have a log on it. So I want to get rid of the log on the left side. So what do I do to get rid of the log base 5 on the left side? I make 5 the base, the exponentiate. If I exponentiate the left side, I have to exponentiate the right side. Make whatever the base of your log is. So if that's log base 10, you make 10 the base. This is log base 5, so we're making 5 the base. That cancels these out and gives us x plus 6, parentheses, x plus 2 is equal to 5 to the first power, which is 5. Now we have a regular algebra problem. What do we need to do to solve that regular algebra problem? What do you mean distribute first? All right, so we multiply all that together, right? And that's going to get us x squared plus 8x plus 12. A little closer to normal there. Now what? Now what do we have? You can do quadratic formula. You could also factor, complete the square, whichever way you want to solve that. I don't care which way you do it. I'm going to factor this one because I know it will, because I know what multiplies to be 7 and adds to be 8. Quadratic formula is a good option as well. Okay, so whichever way you want to. So that'd be x plus 7, x plus 1. And then do what with the factors? Well, set them equal to 0 and subtract to solve. And then there we get x equals -7, x equals -1. Both of them are negative answers on this problem. So we need to go back to the original and see which one gives us a negative inside of the log. -7 doesn't work because in the first log base 5 of x plus 6, that's already a -1. Well, if I plug in -1 in that spot, it turns out to be log base 5 of 5, and that works. And then log base 5 of 1 is the next piece if I use -1. So x equals -7 gets thrown out. X equals -1 is the only answer we keep in this one. Well, there's a case where we kept a negative answer. All right. Not too bad. It's pretty easy. Okay. All right. Example C. Natural log of x plus natural log of x minus 4 equals natural log of x plus 6. So we got natural logs everywhere. Here log, there log, everywhere log, log. So what can we do? Multiplication on the left side. So that's going to get natural log. I'm just going to go ahead and distribute that out. Is that okay? X squared minus 4x. Since I know that's what will happen. Now, how do I get rid of a natural log? E. Remember, natural log is log base E. So I'm going to exponentiate with a base of an E on this one. Exponentiate with a base of an E. So that gives me the equation x squared minus 4x equals x plus 6. Now what? Yeah. I was afraid of that. That's the program I'm using to cast up here. Since the Chromecaster is locked out right now. All right. So what do I need to do to this? Get it equal to what? 0. That's the name of the game. So subtract x. We'll subtract 6. It'll be x squared minus 5x minus 6 equals 0. Yeah, -6, positive 1. So x minus 6 equals 0. X plus 1 equals 0. So we get x equals positive 6. X equals -1. Which one of those gets thrown out? The -1. So x equals 6 is the only answer we have. All right. not too bad. We're getting rid of logs using exponentiation, based on the whatever the base of your log is. So let's look at this. Two to the x power equals 5. So we've got an exponential equation here. If that were an 8 over there where the 5 is, pretty easy problem. You turn 8 into 2 to the third power, and then x equals 3. Real easy. But it's not. It's a 5. 5 is not really nice to do 2 to a power to get it. If it's a 4, it's 2 squared, but it's a 5, so it's messed up. So what we need to do is be able to get that x out of the exponent area. So what we want to do is cancel out this base of a 2. So what log would cancel out a 2 as the base? Log base 2, yeah. And I'm writing an extra step here. And then I would normally just write it onto the problem there, but I'm writing it as an extra step. So these two cancel each other out. And then we get just x equal to log base 2 of 5. Let's get a decimal approximation for that. Log base 2 of 5. We want to be able to get an exact answer and a decimal approximation. So hit the math button. We want to go to log base, so the quickest way is just press the up arrow. And then we got log base 2 of 5. And let's go 3 decimal places. So that would be 2.322. So now remember that you can use the change of base form if you wanted to. You could do log of 5 divided by log of 2. Get the same answer. If you've got the older version, or you just don't want to go through the menu system to get there, you can do it that way. Okay. All right. Let's go right here. It's a pretty small problem. So let's do 8 times 3 to the x equals 5. So a little bit, maybe an extra step in this problem. So we got 8 times 3 to the x. Can I get rid of that 8? What's going on between the 8 and the 3 to the x? Multiplying. So to get rid of it, we would divide it, right? I know you're thinking, well, we're doing logs, and there's not a log in that problem yet. So I'm going to get the part that has the variable in the exponent by itself before you do any log stuff to these. All right. And then, yeah, that's when you can do log base 3. And that's going to be x equals log base 3 of 5/8, which is approximately how much? Math. Log base 3, 5 divided by 8. Negative 0.428. There's an exact answer and a decimal approximation for that. All right. Pretty simple so far. We're just using a log to get rid of one thing that has an exponent with a variable in it. Gets a little bit more complicated in the next example when we've got 5 to the x minus 2 equals 3 to the 3x plus 2. So we've got 2 different bases that both have variable exponents. So it makes it, very difficult to decide, okay, what log do I use to get the exponent down? Here's the thing. You don't want to use the log base 5 and you don't want to use the log base 3. Because neither of them is going to work with you could do log base 15 is just introducing a whole other log as well. So if we're just going to introduce a whole other log, let's use one of the common ones, either natural log or log base 10. Okay, if we're going to introduce something that's not a 5 or not a 3, then we're going to use one of those. This textbook tends to use the natural log most of the time. That's the way that I'm going to do this. You could use the log base 10. It works the same way. You get the same answers, decimal approximation-wise. But for the exact answers, just to keep you consistent with what this textbook does and what your tests and quizzes will be, we're going to use the natural log to do that. It's also quicker to write. It doesn't matter which one of those you use, though, technically. Okay, so if that ever comes up in a math class. All right, so what we could do here is take the natural log of 5 to the x minus 2, and then take the natural log of 3 to the 3x plus 2. What that allows us to do is bring this entire exponent for each of those to the front. So we get x minus 2 times the natural log of 5, and then we get 3x plus 2 times the natural log of 3. What we've got to keep in mind is natural log of 5 is what? In general, it's a number or a variable. The natural log of 5. It's a number, right? It's like it was 6. It's not 6, but if it were, that's what we're treating this like. So if this is just a number, now that we've taken that log and brought the exponent down the front, it turns it into a multiplication problem here, and we can distribute this natural log to both of those terms. We want to do that so that we get natural log of 5 times x minus 2 times the natural log of 5. Do the same thing on the other side. 3x times the natural log of 3 plus 2 natural log of 3. We want to do that so that we can get the things that have x's on one side, the things that don't have x's on the other side. Okay? And we want to try to avoid a rational expression if at all possible. I realize we could have just divided over here and then divided over there, and then we get a rational expression, which is a whole nother game of solving. Much easier if we leave it this way. Okay, so now let's move stuff. I'm going to move the 2 natural log of 5, and then I'm going to move the 3x natural log of 3. Okay. These are going to cancel so that the left side is now x natural log of 5 minus 3x natural log of 3